This is 4-1, identifying linear functions. So let's break down these two words real quick. Linear. Let me zoom in. Okay, linear means line. So it would be a straight line, no curve to it. And a function would have to pass the vertical line test. So I'll remind you of what that looks like. And in addition, it could be no repeated x values, no double domain. That was from chapter 3. So we'll be looking at that again. So a couple things about a linear function. A linear function is a function that forms a straight line and can be written in the form y equals mx plus b, where x is the independent variable and m and b are real numbers. And so we'll be learning more about this in this chapter, but m is slope and b is y-intercept. Some of you might remember that from last year. And a linear equation is any equation that can be written in standard form. Standard form is ax plus by equals c. And we'll take a look at that throughout this chapter as well. Okay, for 4-1, one type of problem will be asking if a function is actually a function and if it's linear. So the function part is from chapter 3. So we need to see if this passes the vertical line test. You draw a vertical line down and you see if it's repeating. So it only hits once here, so that's good. So this one's a function. And is it linear? Does it form a straight line? Well, the red line is a perfectly straight line, and so therefore it is linear. Okay, here we have a line. So we have the linear piece, and we need to see if it's a function. So I draw a vertical line somewhere through it. And does it pass the vertical line test? Yes, it only hits once. So again, it's a line, so it's linear, and it's a function. Okay, and example C. Is it a line? Yes, this is linear. Is it a function? So if I draw my vertical line down, I'm hitting everywhere on this line, all these different points, so it's repeating. The x value is repeating, and so therefore it's not a function. So we would just write not a function on this one because it said identify whether each graph represents a function. No, or not a function. We only care if it's linear, if it is a function as well, because to be a linear function, you have to be linear and a function. Okay, in example C, I'm going to draw my vertical line to check my vertical line test. Well, I hit twice right here. So anywhere along this, I'm going to hit twice. Even this one where I hit, looks like I'm only hitting one time, it doesn't matter because I've hit twice somewhere else on my vertical line. So this is not a function. It also wasn't linear, but the first part of the question is identify whether it's a function. And this next one, is this a function? Yes, this is a function. If the graph does represent a function, is the function linear? Not linear. So it is a function, but it's not linear because it has a curve to it. It's not a straight line. When you're looking at a table of values, to see if something's a function, you could graph them, but I'm not going to want to graph all of these points, especially this one that has the number 20 on it. So that's one option. Or you can see, is there a constant increase in the x and the y? So look at this, x is going up by 5, 5, 5. So they wrote it here, increasing by 5 every time. We also have to check the y. Well, the y is decreasing by 4 every time. So it has the same each time for the x and the y. And so therefore it is linear. If it's not linear, we might have something like this, increasing by 2, increasing by 2, increasing by 2. So that part looks good, but here's where we go wrong. Increasing by 2, increasing by 6, increasing by 10. This makes it non-linear. Okay, so tell whether each set of ordered pairs satisfies a linear function. Well, the function part, first I'm just looking at all of the x values. Do any of them repeat? No. So this is a function, but I need to see if it's a linear function. And the linear piece, I'm looking at all the x values to see what they increase by. So the x's are increasing by, let's see, plus 3, plus 3, plus 3. And let's check the y's now. 4 to 3, minus 1, 3 to 2, minus 1, 2 to 1, minus 1. So they're increasing by the same amount on the x and y, and therefore it's linear. So this is a linear function. Let's check B. First, check if it's a function. So I'm looking at -10, -5, 0, 5. None of those repeat, so this is a function. And now let's see if it's linear. So check from the x value. Oops. -10 to -5. Well, that's increasing by 5. -5 to 0, increasing by 5. 0 to 5, increasing by 5. So this one's good. Let's check the y's. 10 to 4, -6. 4 to 2, -2. I can stop right there. 2 to 0 is -2. But this is not decreasing by the same amount, or increasing by the same amount. So therefore it is not a linear function. It's a function, but it's not linear. So I actually already know that this equation is a linear function because it's in the form y equals mx plus b. Okay, there's no exponents, there's no absolute value. So there's a couple other rules with it that I'll get to, but this is definitely linear. But another way I can tell is I can make an xy table. So if I pick my x values as 0, 1, and 2, for instance. Well, if I plug in 0 into that x spot, 0 plus 3 is 3. Okay, now let's plug in 1. 1 plus 3, 4. Let's plug in 2. 2 plus 3, 5. And let me check my, first of all, none of my x values are repeating. I made them that way. So it's definitely a function. And I'm increasing by 1 every time on the x, and I'm increasing by 1 every time on the y. And so this is definitely linear. And I can graph it to see that it forms a straight line. So 0, 3, 1, 4, 2, 5. And that pattern would continue. So again, it's linear, it's forming a straight line, it passes the vertical line test, so it's a function, so it is a linear function. Y equals x squared, I already know it's going to form a parabola, so it's not a linear function. Oops. So I can make an xy table to prove this. So let's say I pick 0, 1, 2, 3, etc. 0 squared, 0. 1 squared, 1. 2 squared, 4. 3 squared, 9. So 0, 0, 1, 1, 2, 4. Notice I'm already off my straight line. 3, 9 would be something like this. And so this is going to form a parabola. If I had picked negatives, it would have actually been a mirror image on each side there. So y equals x squared forms a parabola, and so it's not linear. It is a function, but it's not linear. Example 4, at another salon, Sue can rent a station for $10 per day plus $3 per manicure. The amount you pay each day is given by this function, f of x is equal to 3x plus 10, where x is the number of manicures. Graph the function and give its domain and range. Okay, so the total cost depends on the number of manicures. And so we can make a graph listing out how many possible manicures. So we could start with 1, 2, 3, 4, 5, etc. If she has 0 manicures, it is actually going to cost $10. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 0 manicures cost $10 no matter what. If she gives 1 manicure, she has to pay 3 times 1 plus 10, which is 13. If she gives 2 manicures, she would have to do 3 times 2 plus 10, which is 16. You can see it's already forming a linear function, even though my graph isn't perfect. 3 times 3 plus 10 is 19. So 3 would be 19. And so there's my straight line. Okay, now the domain. So my domain is my x values. Well, I could have picked 0, 1, 2, 3, 4, etc. My range is going to be all my y values. Well, the lowest, when I plugged in 0, I got 10. And then after that, it went 13, 16, 19, etc.